Hi everyone! Welcome to the third edition of Acoustics webinar. This time dedicated to acoustic calibration services. During the webinar, we will take a look at different types of acoustic calibrations, how they are performed, and also review a bit their role in DEWESoft measurement solutions. First and foremost, we shall begin by just establishing the meaning of the term calibration and also focusing a little bit on why it's so important. Before we perform any kind of measurement, our equipment which we are using for the measurement must be calibrated and checked against known standards if we want to be sure that the readings of the measurement equipment are to be trusted. Consequently, calibration represents a fundamental step in the process of measurement. And why is that so, one might ask themselves? Because it ensures that your instrument accurately indicates the required measurement parameter and also that it's performing to specification. In essence, calibration checks the accuracy of your instruments and also determines the traceability of your measurement. Measurement procedures in acoustics are heavily regulated by standards, such as ISO standards. So, in order to ensure comparability and repeatability of obtained measurement results, we measure according to those standards. Inside these standards, additional requirements for standardized calibration of our measurement equipment are stated. These calibrations of equipment are carried out in an accredited laboratory according to international IAC standards. Some of the most common IAC calibrations include calibration of measurement chain as Class 1 sound level meter, and perhaps calibration of octave and fractional octave filters. We will take a look at both of the IAC standards that describe such calibrations later on. In addition, we will also look at how level calibrators are calibrated, how measurement microphones are calibrated, and how intensity probes are calibrated. By calibrating the equipment used according to the IAC calibration standards and also by following the ISO standards for measurement procedure, obtained results can be used when issuing official ratings for equipment. For example, if we measure sound power and we want to issue a report about the sound power value of our device under test, we want to follow the ISO standard for measurement procedure and we want to have our equipment calibrated according to IAC standard. If we have both of those two things, we can issue official ratings after we complete the measurement. Generally speaking, calibration should be performed in the following situations. Whenever we acquire a new instrument that has not been utilized before, after any kind of repair or modification has been carried out on the measurement equipment, in the event of specified time period or specified usage in operating hours having elapsed, it's also a good idea to carry out calibration before and after a critical measurement, just to ensure that characteristics of the system remain the same during the measurement process. A thing that influences the measurement system are different types of events. For example, unwanted events such as exposure to shock, vibration, or physical damage, or normal events such as change in environmental condition. In any case, after any kind of event, we want to perform calibration to be sure that our measurement system is still performing up to specs. Performing a calibration is also sensible whenever performance appears questionable or indications do not match surrogate instruments. But most often, calibration frequency is dictated by different specific requirements, such as customer specification or instrument manufacturer recommendation for calibration intervals. As we have established the meaning and importance of performing the calibration itself, let's focus next on particular calibration procedures and their corresponding standards. We will begin with one of the most widely used and performed calibration services, Class 1 sound level meter calibration of the measurement chain according to IEC 61672. IEC 61672 is the standard that is most often used when it comes to calibration of sound level meters. Procedures include tolerances and are designed to verify that the characteristics of the sound level meter are correct. Some examples of characteristics that are tested include frequency response of both microphone and filter, the time weightings, level linearity, overrange indication, and additional parameters. Sound level meters are divided into different classes of accuracy, where Class 1 is intended for precision measurements and Class 2 for simple measurements. Approximate accuracy for a sound level meter of Class 1 is 1 dB, and for Class 2, the accuracy is 2 dB. DEWESoft data acquisition systems can be calibrated using the procedure for Class 1 sound level meter in accordance with the international standard IEC 61672. Most suitable data acquisition slice for the job in acoustics is our dual-core series, as it covers a wide dynamic range of 160 dB. We have looked a bit at how sound level meter calibration is performed. So next in range of very often used and required calibrations is calibration of octave and fractional octave filters according to IEC 61260. Periodic tests of octave band and fractional octave band filters, whether as dedicated instruments built in sound level meters or in other measurement solutions, are performed according to standard IEC 61260. When measuring the spectral contents of sound, the signal is divided into frequency band with a constant relative bandwidth. Constant relative bandwidth, or shortly CPB, means that the width of the band is proportional to the center frequency of the band. The most common relative bandwidths are 1 whole and 1/3 octave band. Very similar to the calibration standard for SLM, also in the IEC 61260 standard, two classes of accuracy are stated, Class 1 and Class 2. Class 1 is effectively better as it is more accurate. In addition to performing a calibration of sound level meter and to performing a calibration of octave filters, before performing the actual measurement, microphones that are going to be used should be calibrated for level by utilizing an acoustic calibrator. In order for this level calibration to be effective and true, we need to be sure that the output of calibrator we are using is spot on. For this reason, calibration of the calibrator itself is performed according to IEC 60942. This standard defines three classes of accuracy: LS, 1, and 2. Class LS is intended for laboratory use, while Class 1 and 2 are intended for field use. Calibration is performed at a single frequency, either at 250 or 1000 Hz, and at supported acoustic pressure levels, which are usually either 94, 104 or 114 dB. The calibration is performed using a comparison method by utilizing the reference piston phone as the standard comparative sound pressure level. The report of the calibration includes measurements of sound pressure level, frequency, and total distortion. If the instrument is equipped with an accessory barometer, this is checked at the current air pressure. In addition to before mentioned calibration of complete measurement chain, including microphone, cables, data acquisition unit, and the software part, that can all be calibrated as Class 1 sound level meter, separate calibration of the measurement microphone alone is often presumed. Such calibration of all types of microphones is performed according to IEC 61094. And this is true whether we are calibrating with or without preamplifiers. The sensitivity of the microphone that is being calibrated is measured by comparison with the reference microphone. The two microphones are exposed to the same sound pressure in an active comparison coupler, which contains a built-in sound source. The measurement frequency can be set to either 250 Hz or 1 kHz. The measured sensitivity is, however, valid at the environmental conditions during the measurement. Correction is made for the influence of environmental pressure, temperature, and humidity on the reference microphone. In addition to measuring sensitivity, the frequency response is determined using an electrostatic actuator. This is a widely used tool that can simulate a constant sound pressure on the diaphragm of the microphone, and it can simulate this constant pressure over a wide frequency range. The actuator measurement is a relative measurement, and the results are normalized at the sensitivity measurement frequencies, which are also called reference frequencies, and they are, again, 200 Hz or 1 kHz. Depending on the type and application of the microphone, free field or diffuse field corrections may be added to achieve the required type of frequency response. When it comes to sound intensity measurements, we carry out measurements utilizing a special piece of equipment called the intensity probe. There is a specific IEC standard for calibration of intensity probes. Let's take a look at how this is performed and why it is important. Sound intensity is generally measured with sets of pressure sensing microphones that are attached to sound intensity probe. A set consists of two microphones with phase characteristics which are essentially equal. A very close match is necessary, as even small phase response differences may cause significant errors of the measured intensity. Sound intensity probe calibration procedure consists of sensitivity and phase check. The sensitivity of the microphone pair is measured by comparison with a reference microphone, according to the same procedure as described in IEC 61094 for calibration of measurement microphones. In addition to sensitivity measurement and phase check, the pressure residual intensity index for the complete system is also calibrated in accordance with the demand stated in IEC 61043. We got to know the fundamentals of particular acoustic calibration procedures in the previous section, so let's now focus a little bit on the strengths of performing these calibrations with DEWESoft. Some of you might already know that as a measurement solutions provider, we are committed to simplifying the measurement world for the user. As we dedicate a lot of effort into providing complete measurement solutions, we are very proud to say we support all of the today stated calibration services, enabling our customers to have a complete system upon delivery. This way, they save precious resources and time and are able to start measuring right away. In order to achieve this, we paid special attention to our customer needs when shaping our calibration services. To ensure the best possible execution and worldwide standard compliance, we partner up with an experienced, internationally accredited calibration laboratory. As a result of this partnership, we are able to provide a highly competitive service featuring the following: worldwide valid calibration to traceable international standards, meaning the performed calibrations will be valid all around the world. 5 working days turnaround time, state-of-the-art calibration management system which is tailored to the user. This way, the user gets notified when calibration is about to expire and calibration process can be tracked while being carried out. We support digitally signed certificates that are easily accessible from anywhere via included link. And perhaps most importantly, our partner lab has more than 35 years of experience in sound and vibration measurement equipment service, ensuring the highest possible quality of execution. Alright, this was a brief overview of calibration services and how they are performed with DEWESoft. I would like to thank you for your attention, and please remember, for the right results, calibrate with DEWESoft in order to be absolutely sure you measure correctly. Thank you everyone for your attention and have a great day. The Q&A section will follow shortly. Feel free to pose any questions and ask for additional information. I will be, of course, glad to help you. Thanks again, and bye-bye.